Okay, so yeah, welcome to the first ever STEM Village Virtual Symposium. So the STEM Village kind of came about because of, well, there were multiple other groups who really kicked this off of trying to increase visibility in networks for the LGBTQ plus STEM community, including LGBTQ plus STEM, Pride in STEM, or STEM. There was LGBT STEM Day and House of STEM. So one of the things that we really wanted to do was also create a community for Scotland as well, to make it more focused on this area. And the aims of this were to kind of create a network for the LGBTQ plus STEM community in Scotland, increase visibility, and to increase the visibility for our community, and also introduce Scotland to the global community. And actually, one thing that I didn't mention was the name of the STEM Village came about because of the idea that gay villages in the past were seen as safe havens for the LGBTQ plus community. So that's how the two things came together. And yeah, one of the things about creating a community like this in Scotland is, I don't know if you're aware, but just recently, Scotland became the first nation to create an inclusive curriculum across all of the school stages. And one of the things that we would like to do is, or one of the reasons of increasing visibility is so that those who are thinking about what their careers are going to be can see themselves reflected in the STEM community. So that's kind of where this really came about. So I don't want to labor this too much. So I'm just going to move on quite quickly and just quickly go through the code of conduct that we've set up for the day, which I'm sure everybody would be adhering to without even seeing this. But really the main points are that, you know, we obviously want everyone to enjoy the conference, and we want everyone to be treating each other with respect and dignity, to respect everybody's pronouns. We want all communication to be appropriate for a professional audience, and for people to be considerate of people from different cultural backgrounds. We won't be publicly sharing communications or anyone's personal circumstances. We want people to be kind to each other, not insult each other and put each other down. And we want everyone to agree that harassment and exclusionary jokes are not appropriate. And this harassment can include offensive verbal written comments, deliberate intimidation, stalking, following, harassing photographs, that kind of thing. And we will also, hope that people will contribute to discussions with a constructive and positive approach. So if you do have any issues that you need to discuss, please contact one of the hosts in the webinar, or alternatively, you can contact us at thestemvillage@gmail.com to discuss any concerns that you might have. Also, you should have received the full document with more details of this, because it's not only these points. And with that, what I really want to say is a massive, massive thank you for today. First of all, to all of the organisers and chairs, to Kiri, Mehmet, Katie, Brynley, Avery, Vinod, Michael, Sam, Sammy, Crystal, Melvin, and Cameron, who honestly, I couldn't have done this without all of you. You've helped to shape this and drive this, and I really appreciate all of the time and energy that you've put into this. I want to thank all of the speakers and all of the participants in the poster session. We all really appreciate the time and energy that you've put in as well. And I want to thank all of our funders, so various parts of the University of Edinburgh, including the Institute for Academic Development, the Scottish University Life Sciences Association, SULSA, and the Physiological Society. So please follow along on Twitter as well, using the hashtag that we have been sharing. Feel free to share your own experiences of the symposium. And yeah, with that, I think it's probably time to try and get this show on the road. So thank you for listening to me. And with that, it's my great delight to start session 1 of the symposium, which will start with a fantastic talk by Izzy Jayasinghe, who I believe should be able to. Izzy, can you share your screen or?
I will share my screen. I'm told that I'm unable to share my video.
Okay, 1 second. I'm going to upgrade you to co-host so that you can.
Brilliant.
There we go.
I'm just going to share my screen. Hopefully I'll share the right one. So is that visible to everyone?
Yes.
Brilliant. Thank you very much, Matthew, and the STEM Village organizing team, first of all, for inviting me to give this talk, and particularly to start the proceedings with which looks to be a great lineup of speakers. I also want to acknowledge STEM Village for the massive effort that's gone on to this the symposium, noting that they had to organize a physical symposium, and after the lockdown was announced, move that to an online event. So massive kudos to the whole team. I'm going to briefly start with a brief introduction of who I am and where I'm coming from before I sort of launch into data so early in the morning. Um, so um, I am a UKRI Future Leader Fellow, a Senior Research Fellow in the University of Sheffield in the UK. And by training, I'm a biologist, but my research these days focuses on optical microscopy, a domain which is teeming with sort of new innovations and really competitive research. And I find myself perhaps the odd one out in that environment for a number of reasons. And those are the reasons that have kind of brought me into EDI, equality, diversity, and inclusion work. And that's mainly because I'm a trans woman of color, of Asian descent, and I'm also the lesbian partner to another academic. I was born in an environment which is sort of war torn in Sri Lanka, and grew up observing violence that was sort of charged racially, as well as had left no room for any kind of diversity, or if you belong to a minority. And navigating a career in academia, I've been an immigrant, so I've lived in 4 different countries. Some countries have been really welcoming, so much so that I think I call them home, and some of them not quite so. So my experience has really kind of been the driving factor to really seek out ways to engage with equality, diversity, and inclusion. And I've been involved with a number of organizations over the last few years, 2 of whom I want to mention: Tiger in STEM and LGBTQ STEM, whom you could follow on Twitter. And a lot of the material and the data that I will present to you actually come from these 2 organizations, particularly Tiger in STEM. Now, it's probably a good chance to introduce the JEDI in the room. We all know what EDI stands for: Equality, Diversity, and Inclusion. We are, I mean, as an LGBT community, we are familiar with the idea of inequality. It tends to involve a system that is partial to one or more demographics, and certainly disadvantages and marginalizes other demographics. And in this cartoon by Tony Bruce, the system is the tree. And most institutions that we work in, universities, research institutes, government organizations, we tend to work on equality. And that is the principle of closing the gap by kind of giving a lift to all the groups. But the problem is that inequality still exists, even though it's smaller. And that brings the idea of equity, which is to really lift everyone to the place of equal opportunity. And that means that you are perhaps taking positive action to really help the really disadvantaged minorities. Now the J in JEDI is justice, where it is. I personally think of justice as an aspirational concept. Certainly in the UK, in UK STEM, we're far from it, and it is a concept where we correct the system to be impartial and fair, so that from equal opportunities, from a point of equality, everyone can have that access. Now, when you engage with EDI groups and organizations, particularly in universities, here in the UK, we have groups like Athena Swan, you often get pushback. And this is kind of an exemplar comment about why we need to talk about diversity in a place of scientific research. And what I've found is that one of the most effective counters and one of the most effective ways of engaging and really dispelling myths about it is to actually talk about the diversity data. So, what we're working on is sort of guided by the data rather than something that is sort of out there. I want to draw your attention to one document, particularly in the LGBTQ community in STEM in the UK, that has been quite helpful in the recent past. This was a document put out and endorsed by a number of professional groups in the physical sciences following a series of surveys. And they kind of shed light on a number of key issues. If you look at colleagues who consider leaving the workplace or leaving the disciplines, they found that LGBTQ people considered leaving their workplace more than the non-LGBTQ respondents. And they explored a number of different reasons. For example, exclusionary experiences or behaviors, intimidation, harassment and offensive language and so on. And they looked at how different disciplines fared, but they also very critically shed light on the fact that trans and non-binary colleagues tended to experience more of this negative, or more of those colleagues tended to experience negative behavior that led them to feel that way. Now I'm going to pause there because I think there is a blind spot in this kind of data, particularly in the LGBTQ data that I want to highlight. For example, in this report, which is quite a lengthy report, there was only one mention of the experiences of BAME. So for those who are not in the UK, BAME stands for Black, Asian and Minority Ethnic Groups. There was no real mention of them except for one point where they say they did not find any significant difference in the way BAME colleagues experience their workplace, and that also extended to people with disabilities. There was a quote, one individual who identified as a pansexual trans woman who kind of implied that it is perhaps more difficult in today's environment, particularly in the UK, to be out as trans than to talk about race or disabilities. And as someone who's a trans woman of color, I have some question marks about that. And I also have some question marks around this angle of and analyzing the data. And the reason is that if we actually look at how people of color, who are LGBTQ, experience workplaces and education, there's something to be learned. And this is an example that comes from the 2015 US transgender survey, where they looked at people who experience this kind of negativity in college or in school. And they found that people who are indigenous, Black, and particularly Middle Eastern, so these are trans people who are of color, experienced worse things than their white counterparts. Note that there's a lot of notable disparities between the different groups, so you can't just bag them as one group as BAME or people of color, because Asian respondents had an experience comparable to white trans people. And the story is the same for people who go on to drop out of school, people who are unemployed. So there is data, and it is a known fact that people of color who are LGBTQ experience academia, school, universities poorly compared to their white counterparts. And this is kind of a graphic that I put together during Pride Month just a few months ago, which kind of maps out all the negative things that Pride Month brought. There was a famous fiction writer who took to Twitter to punch down on the trans community and so on. But coinciding with Pride Month was the latest wave of Black Lives Matter movement. And that kicked off, and everyone talks about what happened on the 27th of May when George Floyd was lynched by a few white police officers. But a story that's perhaps talked less about is what happened on the 29th of May. Tony McDade, who's a Black trans man who was shot dead in a town in Florida, which kicked off Black Lives Matter riots there. So, Black Lives Matter, which, extended and still is ongoing, is not just a cis straight movement. It also belongs to the Black queer community, and they might seem like sort of finer details, but these details are forgotten. Now, I wrote a blog piece, which I'm not going to go into too much at this stage. Please have a look if you're interested. But I want to launch into the reality of BAME or people of color in the UK, and there's a real gap, and I show this for people of color in general, because there's a gap in the data of the experiences and the treatment received by LGBTQ people who are Black, Asian, or ethnic minorities. If you look at the funding experiences, so grants and fellowships that are awarded to PIs, so principal investigators in the UK, typically white applicants tend to have a success rate of about 27%, so about 1 in 4 applications get funded. And for PIs of ethnic minorities, so that includes Black and Asian and other ethnicities, that is around 17%. And that means that they have to write about 5 or 6 applications to get one funded. And that is not really what we call equality. And if you look at the amounts that are funded, so not just the success rate or the number of grants, but the value of the grants, comparing between ethnic minorities and white applicants, and these bars stand for mean and median. If you look at the mean, on average, grants that are funded for PIs of ethnic minorities tend to be about 20% less money. And we don't know why, but it is a significant problem, and these are quite large numbers of grants that that this data come from. And this, I think, is perhaps the most telling story about how in the UK we value the scientific contribution of people of color. This is a pie chart of all the scientific awards that have been made since the record started, except for the awards that are ring fenced and separate. They're dedicated to Black or BAME researchers. Out of the awards that are up for grabs for everyone, 99% of them go to white scientists. And that is a sorry story to tell. And I think that the truth in EDI or JEDI is really, a lot of it is in the data that we have, but a large amount of it is actually in the data that we are missing. Because in the UK research councils, they do not have any diversity data relating to LGBTQI people. They have been aware of these problems. There have been some open letters pointing this out, and they are still not collecting that data. And also we heard in the last few weeks that of the funding that has gone out for addressing COVID-19 in the UK, so £4.3 million have been awarded across a number of grants. No money has gone to a grant led by a Black researcher. I think there are some BAME or Asian researchers who are co-investigators who have received some money, but really there's a huge disparity in the way that scientific funding is allocated. So the question arises, how do you really champion JEDI in our STEM organizations? And this is by no means a comprehensive prescriptive list, but at the very top of it, I would say, gather and examine data and gather as much data as possible, because the data tell us a fuller story. Also, don't underestimate the power of student activism, especially in the UK universities, where the university leaderships and the managements are terrified of what the students think and feel. And the reality is that, especially if you're talking about LGBTQI communities, the student population has a larger proportion of LGBTQ people than, say, the university leadership and the higher academics. Design codes of conduct and policy documents to safeguard the identities and the rights of LGBTQI people. The other really crucial action that needs to be taken, especially in 2020, in light of Black Lives Matter, is to really include people of color in decision-making in our EDI organizations and bring them into the leadership. And don't just bring them into the leadership, let them make decisions. Don't lock them out of your activities or the really critical decision-making. Don't gatekeep, include them. And also don't go along with the way things are. If you're in an organization or in a group, press for accountability to make sure that there's transparency, that people of color, particularly people who are intersectional, are being valued and included. And finally, don't forget the power of positive action. And this is, by positive action, I mean the action that you take to bring equity. And I want to give this example as sort of a final concluding example. About 6 weeks ago, 6 colleagues in the group of Tiger in STEM came together to launch a webinar series. And our thinking at the time was that webinar series that have really become a mainstay in our lockdown tend to be dominated by leaders. So, research group leaders, PIs, who tend to be white male, cis, straight people. And we wanted to give a platform to a more broader range of speakers that are more representative of the physics community. And we came up, we were not a large group. We are all volunteers, not working with a budget. So everything was done on free software or things that we were out of pocket. And we came up with a small series, and we managed to run so far 4 webinars. And just to show you some data, across the 4 webinars so far, we've attracted 700 or over 750 attendees or views. About 2/3 of them attended the actual webinar, and about 50% of them stayed over for the full webinar. And I think that the story this tells us is that diversity actually has a place in STEM. Creating a diverse lineup of speakers does not mean that we're compromising on the quality of our work. In fact, all the talks were world-class and well received. The engagement and the questions that we had during the webinars were excellent. So I hope that this kind of data, especially looking at the data, motivate you out there to think carefully about inclusion and bringing justice to a system that is currently not equal. And I believe that is the end of my talk. I leave you with 2 words, kia kaha, which in Te Reo Māori means stay strong.
Thank you so much for that, Izzy. That was an amazing talk. Really, really fantastic. So first of all, before I ask anything, people can ask questions in the Q&A box. Just type them in at the bottom, or people can also put their hands up. And we actually have someone, Zoe, who has their hand up. So I'm going to unmute you, Zoe, to ask your question to Izzy. Wait. There you go, Zoe.
Thank you, Steve, for that talk, Izzy. That was really great. And I think what was really helpful for me as a white person is actually the tangible actions. One question I do have, though, you said about kind of using data. I mean, in my experience of kind of talking to people about this, data doesn't always convince people as scientists, which is really which I find as a scientist really disappointing. What would you say is then the kind of the next strategy that either you have from experience or that you've seen other people doing that people like myself, white people like myself, can use to push for change?
I think it's a really valid question, and it's a really relevant question that a lot of us who work in EDI currently, I think quite a lot about. And I think there are two aspects to tackling this. One is that the data has to become more comprehensive. So, for example, the graphs that I showed about the value of the grants that are funded, that graph represents only 20% of the applications that are considered by the UK Research Council. And we don't know that the remaining data because that data hasn't been released. So the data has to be full, they have to be granular, and they need to be, they need to be consistent. And so there's some work to be done. And for those who undermine that, and I think that has to be taken as a sign of cynicism. And cynical behavior comes when the structures in universities and leaderships are packed with one demographic or one or few demographics that benefit from it. And this is why it's really important to really include people who can represent those minorities and the marginalized groups. Until you do that, what you get is a sort of allyship that I tend to call conditional allyship, because it's the situation where we look at the data and a small group of people interpret that data in a certain way that is still not the full picture, and they go away and make decisions that are not effective to changing that status quo. So I think until we do address all of those issues, we are going to get disputing kind of behavior.
Mm-hmm. Yeah, thank you.
Okay, so we now have a couple of questions in the Q&A box. And by the way, I'm sure you're not seeing the chat box. Everybody is clapping and saying how much they loved your talk. Amazing feedback. Jay Greer has said, hello, thanks for a wonderful talk. How is it that scholars of colour are being underfunded? This is actually a question that I had as well. Is it that their peers are not reviewing their proposals fairly, or the funding agencies are funding unequally, or something else? You know, what's the point or points that people's behaviours are resulting in disparities?
It's a really complicated question, but thank you for raising that. I think the short answer is all of the above. So the review process is not fair. And it's also a system that's structurally biased. And you know, it's a system that has put up lots of barriers. And particularly my colleagues in Tiger in STEM have been writing papers about this now, about the barriers that are faced by the different marginalized groups, so LGBTQI colleagues and people of color, women, people with disabilities. Now, the issue is that that structural bias has to be weeded out, and that means reform, positive reform that is tried and tested and driven by the data. But I think also the first step towards that is acknowledging that there's a problem, and the behavior that we've seen from the leadership of people who are really tasked with sort of allocating these funds, and the people who are providing the leadership for that process have tended to give pushback. And there's a lot of them among them who are really passionate about justice, equality, and diversity and inclusion. But there's a small number of them who have tended to refute that. And I think the problem is that situation is probably going to change now that there's conversation about it, but that change is going to be glacial. I would say that I'll be lucky if in my professional lifetime, this system actually changes to one that is equitable.
Yeah, I can imagine. You see just how slowly everything works and moves, sadly, and yeah, all the pushback. So we have time for one more question, but because there are quite a few questions coming in on the Q&A box now, after when we move on to the next talk, would you be able to maybe just type some of your answers to those people? Or alternatively, I can just give you your contact details and people can then get in touch and ask.
Yes,
directly?
so I will share my title screen again, if that's possible, so that people have my email address.
Yep, that should
But yeah, if there are questions, I'm happy to answer now if there's time, or by email or Twitter.
Amazing, thank you. So we have, yeah, like I said, quite a few questions, but the next one up is from Jessica, who's asking, how do we make sure that the data in the future asks the questions that are missing from the current data? And how do we make that happen?
So there are a number of obvious gaps currently, and that is, for example, data relating to LGBTQI people tends to be a bit thin, and those are fairly obvious strategies to remedy that. There should be questionnaires and surveys to gather that data. And really, overall, to get access to the full picture, we really need buy-in from the guardians of this data. So if we look at the research funding data in the UK, the UKRI, the UK Research and Innovation, has that data, and they have to make a commitment to make that publicly available, make it transparent so that there's trust in the system. But in the more long term, the data ideally should be backwards compatible, but also there has to be a degree of flexibility in the way we collect data. For example, currently, people talk about including transgender people in these diversity surveys and non-binary people. But what is perhaps not widely acknowledged is, the other gender identities. And, there's still, in the year 2020, it's a culture of disputing some of the other identities that are real. And so we will see over time society improving and society becoming more welcoming to all of us. And there has to be some flexibility in the data gathering to include the experiences and the identities of those people.
That's great. Thank you so much, Izzy, for an amazing talk, really powerful talk. Like I said, there are still a few questions. Unfortunately, we do have to move on, but you have Izzy's contact details, and yeah, I mean, this is the kind of thing that we could talk about for hours and hours and days and still not not solve the many problems that there are, unfortunately. But looking forward to having way more conversations about this. So thank you again. And with that, we are going to move on to the next talk of the session, which is from Giles Oldroyd, who I believe should be able to. Hi, Giles. You should be able to share the screen.
I'm about to share my screen.
Excellent. So next up we have Giles Oldroyd, who's going to be talking about sustainable solutions for global food security. Thank you very much, Giles.
Thank you very much, Matthew, and thank you to all the organisers. It's a fantastic and I think very important symposium, and I'm very much looking forward to the day. So I'm going to do a combination talk where I'm going to talk first of all about my science program, and then secondly I'm going to talk about my sexuality and how it's influenced my professional life. So I'm going to start off talking about my science program. I'm a professor of crop sciences at the University of Cambridge. And my research is focused on how plants acquire the essential nutrients that facilitate their growth. So plants are very good at capturing carbon. You use the energy of the sun through photosynthesis to acquire carbon from the atmosphere in carbon dioxide and then convert that into sugars that then get integrated into amino acids and nucleotides. For the other essential nutrients like phosphate, nitrogen, hydrogen and oxygen from water, they're reliant on the uptake of these nutrients from the soil. And in many cases, the availability in particular of phosphorus and nitrogen can be very limiting and limit plant growth. Now, because of that, in agriculture, we apply these nutrients at very high concentrations. These are the primary ingredients of inorganic fertilizers that we use extensively in our agricultural systems to promote productivity. So this was really the foundation of the Green Revolution, the capability to use these inorganic fertilizers at high levels to drive productivity of our crop plants. Now, the impact of the Green Revolution has been enormous. It's tripled most cereal yields, and now our global population is highly dependent upon that level of productivity. But the system is not very efficient. When we spray those fertilizers on the land, a very significant proportion of them get released into our environment. Some of them wash off into our aquatic systems where they cause this process of eutrophication. This is, you can see, is happening all over the world. Wherever we are growing crops using inorganic fertilizers, we see massive eutrophication in our aquatic systems, but it also has huge implications on our terrestrial systems. And the main effect of it is it drives down the biodiversity of these ecosystems, both aquatic and terrestrial. And in fact, the image here from the Murray-Darling River, that was just the last growth season that was in the news last year. And you can see it's pretty atrocious, killing all the fish in the Murray-Darling Basin. Another point of release of these inorganic fertilizers is that nitrogen can volatilize and be released into the atmosphere as nitric and nitrous oxides. These are extremely potent greenhouse gases and account for about 30% of greenhouse gas emissions, with those nitric and nitrous oxides coming from both transport and from agriculture through the use of nitrogenous fertilizers. Now, when you look at population growth across the planet, it really is very tightly linked to fertilizer use, not surprisingly, because as population grows, our demand for food grows, and the use of fertilizers is so intrinsic in our food production system that really, as a population expands, our fertilizer use expands. With the current global population, we've already doubled the nitrogen cycle around the planet. If we continue in a business as usual scenario, we're looking to quadruple the amount of nitrogen on the planet. So that's putting 3 times as much nitrogen into the planet as a natural system does itself. This will have profound implications on our aquatic systems and also our terrestrial systems and the capability of these ecosystems to support biodiversity. Now, when you look around the planet where that nitrogen is being used, it's primarily restricted to the rich world nations. So we see an awful lot of nitrogen use in agriculture in North America, in Western Europe, in China, and in the wheat growing belt of India. And that is where we experience a lot of these eutrophication problems. But the other side of this equation is what you see in sub-Saharan Africa, where we have very little use of nitrogenous fertilizers. And that's because in these systems, we're dealing with smallholder farmers who have very little access for finances and little access to these inorganic fertilizers. And the result of that is their crop productivity is extraordinarily limited. So they're only producing about a maximum 20% of the potential productivity. And a lot of that poor productivity is associated with the fact that the crops are limiting for nitrogen and phosphorus. So I would say that access to and the application of nitrogen and phosphorus really sits at the heart of equity and sustainability in agriculture. We can't have a sustainable agricultural system unless we deal with nitrogen and phosphorus in agriculture. And we also can't have an equitable agricultural system unless we deal with the access to nitrogen and phosphorus for smallholder farming systems. Now, this problem of the availability of nitrogen and phosphorus in plants is not novel to agriculture. In fact, if you go back in evolutionary time, the point that was most difficult for plants was about 450 million years ago. And this was when plants were evolving to transition from aquatic systems onto land. So this is when the very early primitive land plants were starting to colonize the land. Now, this is an artist's rendition of what a part of Scotland might have looked like around 450 million years ago. And I say Scotland because it has the best preserved fossils of primitive land plants. And it gives us a huge insight into that transition from the aquatic to terrestrial systems. And we know that these primitive land plants were colonizing land by moving out of hot pools, volcanic pools, and they were colonizing the transition zone of these pools, and that's how they were transitioning onto land and evolving the capabilities to colonize this rather dry and barren landscape. Of course, this landscape has no soil at this time because that's built up by plants. So what the plants are having to colonize is rock and sand, a very, very nutrient poor environment. So critical to this colonization of land was the evolution of associations with microorganisms that facilitated that transition from an aquatic to a terrestrial environment. And those microbial associations still exist now 450 million years later and are present in many of our land plants. And when you look out in natural ecosystems, plants are actually utilizing microorganisms in the soil to capture a lot of these nutrients upon which they are dependent. And there's 2 primary associations that I focus on in my research. One is between plants and arbuscular mycorrhizal fungi. And here the fungi heavily colonize the roots of the plant. They get inside the cells of the plant, but also ramify out into the soil and give a very large web-like network through the soil that massively increases the capacity to capture both nitrogen, phosphorus, but also water. And they deliver those nutrients to the plant. And they do so in exchange for carbon. So in many ways, the plant is trading the carbon from photosynthesis for nitrogen and phosphorus from these fungal associations. The second association that I work quite extensively on is that between plants and nitrogen-fixing bacteria. And here the bacteria, the very few species of bacteria, very few species of organisms on this planet can do this, but certain bacteria can utilize nitrogen that's present in the atmosphere, which is a very chemically inert molecule, but they can break that triple bond between the two molecules of nitrogen and convert it into ammonium, which is now a reactive form of nitrogen that plants and other organisms can utilize. So some species of plants have learned to interact with these nitrogen-fixing bacteria and now can get the totality of their nitrogen needs, not from the nitrates and ammonia that's present in the soil, but it opens up access to nitrogen in the atmosphere, which is really an unlimited supply of nitrogen. So my research is really focusing on how we can better use these microbial associations, but both fungal and bacterial, to replace our dependence on inorganic fertilizers and to drive improved sustainability and equity in our global agricultural production. Now, as I already said, the fungal association evolved very early in the land plants, and what I'm showing you here is a phylogeny of all of the plant kingdom. So plants evolved out of green algae, and then we have the primitive species like mosses, liverworts, hornworts, lycopods, ferns, gymnosperms, and then a very large group of the flowering plants, the so-called angiosperms. And we know that this arbuscular mycorrhizal fungal association evolved right at the base of the land plant kingdom and therefore is conserved across all plants, all the way from liverworts through to angiosperms. In contrast, the nitrogen-fixing bacterial association emerged in a select group of the angiosperms and is restricted to certain angiosperms that include the legumes, so peas and beans are the best known species that can fix their nitrogen. Now, because of this very early emergence of land plants, our cereal crops, which are here in the monocots, have the capability to associate with the fungus, but they aren't able to interact with the nitrogen-fixing bacteria. So this is what our cereal crops look like. They can engage in the fungal association, so they can use the fungus to facilitate the capture of nitrogen and phosphorus, but they're still dependent upon the availability of nitrogen that's already there in the soil. So theoretically in agriculture, we can benefit from the arbuscular mycorrhizal fungal association. But in reality, what actually happens is when we apply fertilizers at high concentrations, the plant's pretty clever. It knows that there's lots of nitrogen and phosphorus around, and it chooses not to engage with the fungus because if it can take the nitrogen and phosphorus up directly, then it's free. It doesn't have to swap carbon for that nitrogen and phosphorus. So it chooses just to take up the nitrogen and phosphorus directly. So when we fertilize our fields, we're actually inhibiting the interaction with the mycorrhizal fungus. And that's rather unfortunate because the mycorrhizal fungus is really good at capturing these nutrients that we apply and would be much more efficient at capturing those applied nutrients and delivering them to the plant and would limit the amount of these nutrients that are escaping into the environment. So optimally, what would be a much better scenario is if we were able to rewire that system such that we have the fungal association even when we fertilize the crop plants, such that you can rely on the fungus to capture much more of the nutrients that are present and deliver them to the plant. So for my research on trying to change the way we grow agriculture, this is step one, which is rewiring the fungal association so that we can use it much more in our agricultural systems. And we've at least achieved that in the lab, and this is the only data slide from my research I'm going to show you, where here we have these are barley lines that we are growing under low phosphate conditions or high phosphate conditions. And what we're measuring here is the percentage of colonization by the fungus. And you can see that under low phosphorus conditions, the plant gets colonized. About 75% of its root is colonized by the fungus. But now when we grow under high phosphate conditions, we see a massive reduction in the extent of that fungal colonization. So now it's down at 25%. And these lines here, we are overexpressing a regulator of the symbiotic state. It has no effect when we're growing the plants at low phosphate conditions, but now when we grow the plants at high phosphate conditions, you can see these lines are tending to get much higher colonized. And one of them in particular here, you can see is colonized at an equivalent level to the wild type plant grown under low phosphate. So even though the plants are under restrictive concentrations of phosphate, the fungus is still colonizing the roots to very high levels. So we've demonstrated that at least in the lab, we're able to override this nutrient suppression of the fungal association. And we're just getting ready. We would have been ready next year to take these lines into the field, but unfortunately COVID has rather set us back. So we're probably a couple of years from field tests now, but we're getting ready to move these lines into the field to test the implications on the acquisition of nutrients in a field context. But I'm showing you here the data from some publications just showing how bad we are currently at capturing the nutrients that we apply. Only 33% of nitrogen is captured globally, and even less of phosphorus is captured globally by our crop plants. And so we've got a long way to go, and any benefits that we can get from the fungal association to drive that efficiency up would be both beneficial to how we grow our crop plants, meaning we can put fewer nutrients on, but should be also beneficial for the sustainability of the system, because we should lose a lot less to the environment. Now, ultimately, this is where I want to be. So I'd like to be optimizing the amount of phosphorus that we apply using the fungal association. But ultimately, I want to just take nitrogen out of the equation completely, really remove the need in totality for nitrogen in fertilizers. And the only real way we can do that is to rely on nitrogen fixing bacteria and allow our crop plants to utilize this unlimited supply of nitrogen in the atmosphere. So this is my aspiration of where I'm moving towards in the longer term. And we have a large program of research focused on this. But the premise of this research and this strategic work is the fact that when this nitrogen fixing symbiosis evolved around 80 to 100 million years ago in the angiosperms, it didn't reinvent the wheel. It utilized a lot of the genetic machinery that had evolved all the way down at the base of the land plants and is associated with the fungal association. So the nitrogen fixing bacterial association in many ways is a modified version of this arbuscular mycorrhizal fungal association. And we see the reuse of a lot of the genetic components, the same signaling pathways are used to recognize the bacteria and the fungus. So this is a schematic, a very simplified schematic of what we know is necessary in a legume to allow recognition of these nitrogen fixing bacteria, and then the developmental changes that have to happen in the plant to accommodate those nitrogen fixing bacteria and provide the environment for nitrogen fixation. And here I'm showing you in black what we know is already present in cereals. And in red are the points that we believe are the key innovations that happened in legumes that allowed the evolution of nitrogen fixation. The main take-home message is that cereals already have the basic framework that's necessary for this bacterial symbiosis. We don't have to totally invent or engineer the totality of that association in cereals. What we have to do is rewire the system and connect existing networks that are already present in cereals in the way that they evolved in legumes. And that's a much simpler engineering challenge than rebuilding the whole system in the first place. So this is what we're working on right now, introducing some of these key network modes that we know are critical in a legume to allow the fungal framework to be utilized to drive the bacterial interaction. And we're in the middle of an awful lot of engineering with some positive results, but I don't really have time to go through all of that today. So this is where I would like to be at the end of my career, really optimizing what the application of phosphate, minimizing the amount of phosphate that we need, and really completely removing any necessity for nitrogen in our global agriculture. And if I can get to this point, I think we can achieve certainly a far more sustainable food production system, but we also have the potential to create a much more equitable system because we're putting the technologies in the seed rather than a dependence on large, bulky commodities like fertilizers getting to smallholder farmers. So the people who have funded my work, and I'm very, very grateful in particular to the Bill and Melinda Gates Foundation and the Department for International Development, who are funding a program of research that I lead, international program of research that I lead, to try to achieve these transformations in our food production. And of course, I'm very grateful to both my research group, but also the international program that I lead and everybody who's involved in that. Now, the second aspect of my talk that I wanted to cover, not just me as a scientist, but more completely me as a person, and that is to discuss my identity as a gay man and how it's affected my professional life. Now, unlike Izzy, I'm going to take a very different approach to this. I have absolutely no data in this part of my talk. And I'm really just going to share my own personal experiences. And I fully recognize that everybody has their own path and their own different experiences. But I thought it might be helpful to just share how I've experienced, what my experience has been as a gay man working in a professional STEM and academic context. So for me, I know that to be the most effective and creative scientist, it's really important that I turn up to the workplace as authentic as I possibly can be. And that means arriving in the workplace, fully embracing my queer identity. And the more I'm able to do that, the more comfortable I feel in my workplace and the more creative and effective I am in my workplace environment. Now, I would say that this has been a journey for me. Hasn't always been the easiest thing for me to do. I have always been an out person, but I don't know that I've really fully been present in my full queer identity. And certainly when I was a younger scientist, I found it much harder to do that because I felt less secure in my career and I felt the need to conform to what I saw as the identity of successful scientists. And considering that there were no LGBTQ scientists in fact, at all, neither in my local environment or my subject environment, there was nobody I could see who were successful gay scientists. Conforming to me really meant conforming to a much more heteronormative standard. Now, something that I found really insightful is this book called Velvet Rage by Alan Downs. And if you haven't read it, I highly recommend it to you. And what this book helped me understand is the impact of how growing up as a sexual minority has, and how it creates a level of core shame in our existence. Now, when I was recommended to read this book and told what the premise of this book was, I said, oh, I don't experience shame. I don't think this is me. And then I read the book and I realized, oh my God, that absolutely describes my experiences. And I absolutely experience shame. And in fact, I think it has a very powerful impact on how I work professionally. And the premise of Alan's thesis is that really we, as children, we experience an environment that's not supportive, in fact, quite hostile to our sexual identities. And we become both shameful of that, and we learn, we embody shame in our personal existence, to the point that we don't even aren't even able to recognize that shame. It becomes so intrinsic to who we are that we can't even pull it out and recognize that that shame is present. Another book that I read much more recently, Matthew Dodd's Straitjacket, I think does a really thorough job of describing what it was like in the UK over the last 2 to 3 decades. and perhaps certainly helps me understand how I ended up in a position of carrying quite an extensive amount of shame in my person. I'm just copying here some quotes that came out of Matthew's book that were published in some pretty national newspapers here. And this was at a time in the 1980s when I was a teenager struggling with my sexual identity. And there was a very strong backlash against the gay liberation movement at a time when HIV and AIDS were emerging. And there was very public presented homophobia, both in media and in the politicians at that time. And I think that that really had created a toxic environment across the country and legitimized individuals' own homophobia. Now, I think for me as a person the way I experienced this as a teenager at school was persistent, almost daily homophobic bullying that really wasn't to create an environment that allowed me to explore self-esteem, confidence, and certainly not an environment that facilitated an embracing of my sexual identity. The way I coped with that environment was I excelled at what I could do, and that was academically. I worked really hard at school. I did very well. I always performed well on exams. I got the top grades, and this helped to give me some sense of validation. I got validation from teachers, I got validation from my parents, and I got validation from some of the students around me. And if I'm really honest to myself, I don't think I've ever actually stopped that behavior. And I would say when you look in the academic environment, there are so many different prizes and awards and prestigious invitations to conferences, etc. And I look at, I'm not presenting this list of awards and measures of esteem for just to promote myself, but more to demonstrate that it's very easy to just get rather addicted to this world of success because it helps to validate a sense of insecurity. Now, all of these measures of esteem gives me a large degree of respect within the scientific community. And I massively value that respect. It's very important to me. And it allows me to do things as a scientist that I wouldn't be able to do otherwise. But I think you could look at these measures of esteem in a different way. It's an awful lot of blood, sweat, and tears to compensate for a sense of inadequacy driven by my sexual identity. Now, the academic environment is very broad, and everybody experiences it in their own ways. And I've experienced a very diverse set of different academic environments. I'm lucky that currently, and I'm in a very supportive environment that is very proactive about diversity. But over my career, I've experienced a range of environments from both very supportive to quite toxic. And here I'm just, some of the things that I've heard, and I'm just paraphrasing here, some of the sort of general comments that I've often come across through my academic career. One of them, and I'm paraphrasing obviously here, straight people don't talk about their sex lives at work, so why should you talk about your sexuality? And I think that that's a complete misunderstanding of the difference between a sexual proclivity and a sexual identity. I fully accept it's inappropriate for me to talk about my sexual proclivities at work, but it's very important for me to talk about my sexual identity at work. And those are two very different things. Another general sort of thing I'm paraphrasing here is that academia is full of Guardian reading liberals, so homophobia doesn't or can't possibly exist. And I certainly say that that's not true from my experience, but I think there's sometimes a general sense of this perception that allows academics to be rather lazy when it comes to equality and diversity. I have experienced myself workplace harassment and discrimination, and I've seen prejudice both very explicit and rather overt. And I've seen the discrimination and harassment work in many different ways. Now, for me, you know, I wish I'd known this ACAS definition of harassment earlier. And I think the way I experienced it was a misuse of power through means intended to undermine the recipient. And when I did come to the point of experiencing harassment in the workplace, what that effect did was my foundations were built in glass. I was so dependent on the positive feedback in the workplace to compensate for a sense of inadequacy, that when I did hit a point where I experienced harassment and it was undermining my identity, my foundations were glass. They were so easily broken that it really threw me into a headspin, tailspin that was very unhealthy. And I think that as sexual minorities, we can be extremely prone to that harassment. We can both be targets of the harassment, but I think we're also can be very prone to harassment because we are starting from a place of not being very strong necessarily in our confidence and in our self-esteem. And harassment can be very, very toxic for sexual and gender minorities. Something that would have been extremely helpful for me working through my career would have been some role models. As I said already, there really weren't any role models for me. The only famous gay scientists, and I think this holds today, the only gay scientist that any member of the general public might be able to say is Alan Turing. And while Alan Turing was one of the greatest thinkers this country has ever created, invented the computer and changed the course of history in the Second World War, he still was experienced enforced chemical castration by the state as a result of his sexual identity that most likely led to his suicide at the age of 41. Now, this is a pretty tragic story, and I accept that the state has now accepted that wrong and has apologized for that, and even to the point that now Alan Turing's on the £50 note. But I want my gay role models to not just be outstanding scientists like Alan Turing, but also to be confident and happy in their sexual identities. I need role models who are both scientists and full individuals. And I still think this is an area where we're missing. Where are those role models? They are very few and far between. And something that I've learned to appreciate is that what's really important is that we, within our community, show up and are present and are fully authentic, not just as scientists, but also in our minority status. And to do so both in our local environment, in our national environment, and in our international environment. And I think that's really important both for a personal journey, and this is me marching with the Royal Society of Biology last year in the Gay Pride movement. It was the first time the Royal Society of Biology marched in Pride, and it was very empowering for me to be there. But I think it's also important to the whole community to stand up and be noticed and to be those role models that I think we all need within our community. And with that, I will finish my talk, and I'm happy to take any questions.
Thanks so much for that, Giles. That was a fantastic talk. It was really interesting. And also, I think, especially that second half, you know, there's an awful lot in there that an awful lot of us can really relate to. So thank you for that. We have time just for one question. We've got quite a few science-based questions, but what I think we're going to have to do is after this, we're going to take a note of all of the questions, and maybe we'll put them on Twitter. Or people can email you if that's okay, or that kind of thing. So one question we've got from Marion Crum is, should we be shifting global food consumption to being more legume-based than cereal-based, kind of for the time being?
You know, I don't think that's really possible. Well, firstly, you need a balanced diet. So you need a mixture of legumes and cereals to get a balanced diet. But, you know, there's something that's really important for the way people eat. There's a personal preference is really critical here. You know, theoretically, we grow enough food for everybody to eat well and to have a good and balanced diet. But people choose to eat an awful lot of red meat that takes an awful lot more grains to create that red meat. And we're not very good at sharing all of that food around the planet. So theoretically, we could just grow the cereals and grains that we need, and all be vegetarian and share that food equally across the planet. I don't see much evidence that that's possible. I don't see it happening. We could have that world right now, but for whatever reason, we're not. So, and as a scientist, I can't change that. So I think as a scientist, what I can do is change what is possible and try to drive a more sustainable food production system. And yes, we have to work with policy to try to drive a fully equitable and sustainable system. But, you know, as a scientist, this is the bit that the part that I can play. And ultimately, we have to leave it to individuals to choose how they eat, and politicians of how the global food system works.
Yeah, that totally makes sense. I mean, with such massive global structures in place and human nature and what have you, yeah, it's an incredibly complex area. Okay, so I just have to say there are an awful lot of people just saying how much they really enjoyed the talk, how much they really related to what you were saying. So thank you so much for that. We are going to have to move on to the next talk now, but Vinod, who is one of the organizers, is also putting together a list of all of the questions, because there are quite a few questions now coming in. But thank you very much for your time, Giles.
Of course.
Okay, so next up, I have the great pleasure of introducing Craig Poku, who Craig, I think you are a co-host, so you should be able to share your screen. Hello.
Hello, right, let me just put my screen share on. Right, so everyone should be able to see this.
Yep, that looks great.
Excellent. So firstly, good morning, everyone. Again, thank you, Matthew, for inviting me to deliver this talk. For those who don't know me, my name is Dr. Craig Poku, and I'm an atmospheric and climate scientist based at the University of Leeds. In today's talk, I am going to be discussing this concept of the white voice, and in particular, how it has the capability to distort our definition of progress, with the example I'll be discussing is climate change. I'd also like to thank one of my collaborators, Dr. Rory Fitzpatrick, who was really fundamental when it came to the actual putting together of this research that I'm going to be presenting. So the outline of the talk, I'm going to be addressing 3 key areas. So I'm going to be discussing a bit about me and my background and some of the barriers that I faced on the lead up to me becoming a postdoctoral researcher. The second bit of my talk will then be focusing on some of the research that I've been doing, mostly on the climate change communications aspect. And then the final part of my talk will be discussing this idea of the white voice, where I'll be defining that later in this talk. So a little bit about me. I am a born and bred South Londoner from an area known as Brixton. And as a kid, I was described by my parents as loving, intrinsic, and somebody who was always curious about the world. One thing that I found when I was actually preparing for this talk was at the age of 7, I was trying to work out where did my love for science and mathematics came from. And actually from such a young age, it was very clear that I actually found these to be the subjects that I really gravitated towards. But also when I actually found this profile, there's one thing on here that's totally incorrect, because despite the fact that I said I dislike fighting, I actually have a brown belt in Japanese jiu-jitsu. So clearly something had changed along the lines. In addition to that as well, in addition to my love of science and maths, I also was really big into the arts. And from a young age, I was always involved in theatre and in musical activities. But the reason I wanted to mention both of these activities is because I feel that my combination for my enjoyment of science and maths, in addition to always being a creative person, probably geared me up for becoming a researcher from such a young age. And I really had to try and figure out what really drove my enjoyment and my curiosity to study the natural world. So in 2007, I went to see some of my family in Jamaica. And the best way to kind of describe what got you into meteorology is actually say that you were actually within meteorology. So at the end of so the summer of 2007, I was in Jamaica when a major hurricane called Hurricane Dean had actually hit the island, causing a number of casualties and unfortunately some deaths. And here is an image of Kingston, which is the capital of Jamaica, the aftermath of Hurricane Dean. But the reason I wanted to mention this is because I feel like this, combined with my curiosity of the natural world, probably geared me up for a career in natural sciences and in particular meteorology. And it's really interesting because after that event, I actually was then able to see how mathematics could lead to, could be linked to the natural world, whether that was through physics or whether that was through topics like geography and like physical geography. However, despite the fact that I was so curious and actually was really engaged with these topics, I actually faced a number of drawbacks whilst I was at school. I received comments, for example, where I was told by some teachers that I was not good enough to go to university. In addition to that as well, I also received other comments where I was told I was aspiring too high. I need to lower my goals. And finally, the one that really hit me was that Black students don't do that type of subject. And the reason I wanted to mention these 3 points was that when I finished my GCSEs, I had received the highest grades of the school's history at the time. And despite the fact that I was set a really good set of grades throughout my schooling career, I actually was basically prepared to fail by the people who were supposed to be mentoring me. Nonetheless, it made me really conscious about this idea of biases that are held within Black people, and in particular, especially within white dominated spaces. But nevertheless, I went on to university and I completed a degree in mathematics at King's College London, where I graduated in 2014. I really enjoyed my maths degree because it gave me the opportunity to study subjects such as philosophy or physics. And in particular, this one module that I really grew to enjoy was mathematical biology, whereby I actually was able to mathematically model the idea of fish-eating dinosaurs taking over and how we could actually use that mathematical model to then predict its evolution with a given time. In addition to that as well, I had the opportunity to actually take on board some mathematical research, which a combination of all of these activities led me to end up going on doing a PhD. So in 2015, I packed my bags, decided to leave sunny London and move up to the north, where I decided to embark a PhD in improving fog modelling. Fog is a low-lying cloud that results in your surface visibility decreasing to less than 1 kilometre. And the easiest way to kind of imagine it is that if I'm driving down the road and I can only see 2 lampposts at any given time, you're probably in the fog layer. But the reason I wanted to mention this is that there is a number of different physical processes that result in your fog layer forming. One of them being the understanding of microphysics. So that was primarily the thing that was driving my research. And although my research was primarily in the office, so here we have examples of my desk, which is probably taken on a very tidy day. And I also have my whiteboard, which I would argue just to be like my brain dump space. I also had opportunities to go into the field where I, for example, was able to go to a place called Arran, which is an island off the west coast of Scotland. And that for me was really allowing me to actually see how the observational side kind of fed into the stuff that I was doing in the office. But one thing to be kind of like, I guess, conscious about is that atmospheric sciences is a very white field, and I feel like some of the biases that I faced whilst at school kind of fed into my imposter syndrome whilst doing my PhD. And now the current work that I'm doing is primarily postdoc. I'm currently a postdoc, so I focus on how I can improve fog forecasting over India. And the reason why this is important is because India has high levels of pollution, and the work that I showed in my PhD was able to demonstrate the importance of pollution when it comes to predicting fog. But yet, what was really interesting is that when I decided to say yes to this project, I noticed that a number of the policies that were used to try and help air pollution are driven primarily by white scientists who are outside of India. But yet the work that they've been doing has impacts on marginalized communities. And so I felt that part of the reason as to why I said yes to this is because I felt that I could provide a new perspective on this problem. In addition to that as well, I am really big into communications, and in particular climate change communications. So I have led a number of different projects at the University of Leeds where we have been focusing on trying to understand the public's perception on climate change and what we can do to improve it. And the reason why I want to mention this is because, and this is where the second half of my talk is going to be focusing on, is that within climate change, we sometimes can see it primarily from one perspective, and we're very known for knowing very key people within the climate space. In addition to that as well, we're also probably aware that sea levels are rising, ice caps are melting. But however, how does that example be relatable to, say, groups such as myself, where I came from an inner city London environment? And so this leads me to the second part of my talk, which is going to be focusing on this idea of climate change relatability. So recent reports in February of 2020 from the New York Times have highlighted that climate change has become a growing priority for members of the public. And a consequence of the current pandemic includes reduced emissions, where various sources have theorized that this will result in potential slowing down of climate change. So how could we use an example, a real life example, such as the global pandemic, and in addition to that as well, the reduce of emissions, to adapt our communication strategy that will then result in a more personalized approach, such that members of the public are then more likely to then prioritize climate change and take action. So for this piece of work, it was decided that we were going to conduct a questionnaire where we would ask participants how important climate change was then to them during the past 3 months. And for reference, when I say the past 3 months, we took this survey in June of 2020. The questionnaire consisted of 10 questions where they were a mixture of quantitative and qualitative questions. And in addition, the questions were decided between discussions between myself and researchers at the University of Leeds. Now, the questions that we had were split into 4 key themes. So the first key theme was understanding of climate change. So how much did people actually understand climate? In addition, how much do they feel like climate would have an impact on the country that they're living in within a certain time frame? The second part was this idea of importance and information. So in particular, climate change has become more important to me over the past 3 months. In the past 3 months, I've gained an increased understanding of climate change. And finally, in the past 3 months, I've actively tried to engage in additional information. The third one is actually trying to measure this level of engagement. So in particular, I have engaged in climate change initiatives, either through public participation, advocacy work, or changes to my personal lifestyle. And then the final part was this idea of current events, so improvement of air quality. How can we use an event that's having an impact on us now to potentially then show that there will be knock-on effects? We also asked at the end of the survey, if you could ask any question on climate change, what would that be? And part of the reason we wanted to do that was to demonstrate accountability. There are a number of surveys that go on about communications, whereby as researchers, we're very quick to dictate how it should be driven, but actually sometimes it's really important for us as scientists to listen to what the public want and actually use that to drive our research. The questionnaire was open for a period of 2 weeks. And in addition to that as well, we had a total of 200 responses. And although we do feel that there is a bias within the sample that we asked due to the fact that we shared prior our personal networks, however, we feel that the sample size is large enough for us to gain some preliminary results. So I'm going to go on to the results. I promise that this is the only bit of analysis within this talk. One thing to note here is that of all of our participants, around 95% claim that they understand what climate change is. And we feel that this result was potentially due to the source of our sample group, but we also know that within that understanding, that level is going to vary. We also saw that the majority of our respondents claim climate change is going to have an impact where they live in 50 years, with this number decreasing to 80% if you change that number to 5 years. And the reason why that's quite important is because for some people, they don't want to take action now, where actually there have been a number of studies which have shown that if we don't take action within 12 years, we could be in a bit of a problem. The next part also is to look at how important climate has potentially changed, has become to people over the last 3 months. When we picked the time frame of 3 months initially in June, we actually did this because we wanted to capture the opinions of the global pandemic. However, this also coincided with the George Floyd death in the US. And so we feel that part of the reason as to why climate may have not been as important to some people is because they have felt that the Black Lives Matter, which is something that, of course, we're still talking about, was more important to them at the time of taking the survey. However, one thing to note here is that even if somebody picks strongly disagree, this doesn't necessarily mean that they disengage with climate change information. So with that in mind, we decided to actually take a more correlation approach going forward and say, if you are more likely to say strongly disagree with the importance of climate to one person, how is that potentially going to have an impact on your decision for another question? So for this example here, if you are saying, I strongly disagree that climate has become more important to them, to somebody, then they are also more likely to say, I strongly disagree that I've gained an understanding of climate change. And likewise, the converse argument can be made if you say strongly agree. However, for this group that say that they strongly agree or agree with climate becoming more important, how are they actually engaging in that information? And is that level of engagement potentially able to be adapted depending on what we use as an example? So we then follow this up asking about this idea of how much do people actually talk about climate? One thing to note here is that for those who strongly disagree with climate change becoming more important, they tend to usually not engage with things such as public advocacy. But one thing to note here is that we can see that for those who both agree and strongly agree, the amount of correlation strength is actually a lot less. So it feels as though like people are less likely to actually engage in this information. And I would like to bring up a tweet of a person that I've been following for a while called Raven, Cy Maven, who brought up this tweet, and I asked for a permission to use this. And I use this as an example because when the Black Lives Matter movement gained momentum again in June, we as a society were very good at being able to actually talk about the issues and actually reshare information whilst actually trying to understand our ideas of privilege. However, the majority of people, whilst they're able to engage in this information by talking about it, doing personal changes is a lot harder and is a much more difficult job to do within a time frame. And also note, and one thing I wanted to note is that for those who actually liked this this content, only 32 actually retweeted it with a comment, therefore suggesting that for those 32, they're more likely to do personal changes, whereas for a lot of people, they may have not been able to think about it in that way. And this is something that we actually noticed when we were doing the survey. So for those who had climate to be more important, they are less likely to talk about it. However, they are more likely to do personal action. And so this then makes me then, so when we then came up with these theories, it's what can we do to ensure that people are more likely to want to talk about climate to ensure that we actually have effective action going forward. The final part of this analysis was then looking at this idea of current events, so the idea of improvement of air quality. We noticed that across the board, even for those who didn't claim that climate wasn't more important to them, they believed that because of the global pandemic, that there was an improvement in air quality over the past 3 months. And one thing to also follow up is then we then said, so if you felt that there was an improvement in air quality, do you then think that there is a link between air quality and the slowing down of climate change? And we noticed that across the result, we noticed that across the board, we see that if you strongly disagree in one category, you strongly disagree in another category. But what was really an interesting result that we found is that for those who even claim that climate has become less important to them, which probably means those who claim that climate isn't a thing, they still feel that there potentially is a link between the slowing down of climate change and an improvement of air quality. And the reason I want to bring this up is because this potentially could indicate that a more personalized message is required to communicate climate change across different demographics. For note, we didn't take demographic information for this particular study. However, we are looking at making the study a lot larger, where we can actually try and understand these changes. And so this brings me to the final part of my talk, and it's this idea of the white voice. And part of the reason I wanted to bring this in is because a lot of the personalization messages and a lot of the relatability aspects in climate change, I feel, have been driven by my own personal experiences. But as one of the only few Black British climate scientists that are still active, to my knowledge, it concerns me that we are still having a particular message being put out to the entire population, but it's only being driven by one particular demographic. And so when I came to try and figure out how I could define the white voice, I found this really powerful tweet, really powerful quote, which I'm going to read out here. Watching the media coverage of the school climate strikes, all I saw were white faces, definitely not a reflection of the diversity of the British society. Despite climate warming hitting the global south hardest, why are so few people willing to engage with this fact? The short, frank answer is that the taxes of Extinction Rebellion are designed by and for the middle-class white Britain. And I feel that this is a very powerful statement because this acknowledges the fact that climate change is still being driven by the white voice. And so the final part of my talk is this idea of eradicating minority voices in climate change and what we can do potentially as a group of scientists to actually try and negate this issue. So a consequence of climate change is that we are going to have increases in hotter and more extreme weather events, example of heavy rainfall. And the reality is that minorities are more likely to feel these changes the most. For example, those who are dependent on weather for crop management, as an example. In addition to that as well, surveys have shown how Black and Latino citizens in the US worry about climate change impacts more than white people. However, despite this, climate change is still delivered by the white voice, both in research and the media. And I'm going to just bring up an example of a recent media example of the eradication of minority voices in climate change. So here is a brilliant picture of Greta Thunberg, who has done an amazing amount of work to try and highlight the fact that we as a society need to take action in terms of climate change. Here is another photo, however, of Vanessa Nakate. She is a Ugandan climate scientist who focuses on trying to talk about climate and especially she's a really key advocate of climate change, given the fact that a number of these changes in climate have actually impacted where she lives. Here is a photo of Greta at a conference that she attended earlier this year, whereby she's with 3 of her white delegates. And the reason why I wanted to mention this photo is because actually a lot of the media sources presented this photo, but what they didn't show is that actually Vanessa was in those photos herself. And this could be seen as an example of Vanessa's voices being silenced. So despite the fact that she is there to try and get climate to be spoken about from a minority voice, the media subconsciously ended up cutting her out of the conversation. And you could argue that in a way, the white voice is not relatable to all groups. So an example, air quality, as an inner city London school kid, I may have not necessarily cared of the idea of ice caps melting, but air quality for me was something that was very important. And the reason I mention this is because I'm asthmatic, so hence air quality would have mattered. However, if I, as a kid, had a Black climate scientist come in and demonstrate how air quality and climate could potentially be interlinked, I may have actually been able to take action, and my peers would have more likely considered it as a career that they could have gone into. And so therefore, this demonstrates that in order for us as a group of climate scientists to be able to move forward in terms of actually making people take action, we need to have people of different diversities as well as different ethnic backgrounds to actually then ensure that we can have a more diversified voice. So for this, I'm going to just give a list of recommendations. And although this list isn't exhaustive, this is something that I've been discussing with a number of different academics at the University of Leeds. So the first one is with regards to this idea of education. So it's understanding what leads to the voice of climate change being dominated by a particular group. And this idea of decolonizing climate change. Can we as a group of researchers demonstrate that by decolonizing climate change, people are more likely to engage? The second one is this idea of representation. Now, Izzy picked up on a brilliant point whereby the number of Black and F minority PIs who are successful at gaining funding are so much less than our white counterparts. But the reality is that if you've got poor representation at the lower end, so as an example, I was the only Black British earth scientist in my school's history for about 10 to 15 years, then the reality is that if I'm the only one, then the chances of me getting to the point where I'm applying for funding is so much less. So therefore, we need to look at potentially securing funding for BME students who are interested in climate. We need to do more outreach in areas that have high minority populations that actually demonstrate the link of climate change to their society. And in addition to that as well, focusing that actually it's not a white person subject. The third one is actually talking and advocacy. Why do non-white people feel comfortable, not feel comfortable in engaging in climate in the highest level? It shouldn't be left to me as a Black climate scientist to be having these conversations. It should be me and a range of Black climate scientists to be able to actually discuss these issues. It should be focused on, we should be able to actually diversify that voice. And then the final one is this idea of relatability. So I mostly focus on it from a kind of race perspective. However, the fact that one message may be applicable to one group may not be applicable to another group. So there's this idea of how can we adapt our climate change communications approach. Although these are suggestions based on the research that I've been doing, I do feel that it will take us in the right direction as a community. And with that in mind, I would like to thank you for listening to my talk. If you would like to answer any questions, my Twitter is c_poku93. And I've also left my email address here, which is c.y.a.poku@leeds.ac.uk. And I've also linked some of the articles here that I've spoken in this particular presentation. Thank you.
Thank you so much for that, Craig. That was such a fantastic talk. Like all the talks this session, but it was really, really interesting, really engaging. So we've got a few questions and Kiri is going to pick those up for us.
Thank
you. Okay, can everybody hear me?
Yep.
Lovely. So we've got a question from an anonymous attendee, and they say, really interesting point about accountability and making sure we are researching what people want us to in science communication. Do you think that accountability exists or should exist in science as well?
I do believe, from my perspective, that accountability is required in order for us to be able to move forward. When I was having a chat about this recently with a number of, so I'm currently one of the coordinators of the Black and Geoscience Week that will be happening in a couple of weeks. And when we were having these discussions, one thing we noticed is that we were very quick to be able to talk about brilliant white scientists. However, none of us were able to kind of point or figure out from the top of our heads, Black scientists or Asian scientists or people who are really prominent in the climate field. The reason I mention this is because whilst I'm able to talk about the communications aspects going forward, in order for us as scientists to also go forward, we need to actually demonstrate that there is a bias in the way that we think, especially when it comes to things whereby the science that we're delivering will also have large impacts on minority groups. I hope that answers the question, but if it hasn't, feel free to just drop me a message because I can probably articulate it better over email.